Namaste and good afternoon, everyone. Thank you for joining our program. This is a 2 hours course. Actually, it's a workshop based on Python programming for computational drug designing. We just divide this session into two sub sessions. In the first session, we will be dealing with some important modules that can be used for drug designing using Pythons, and later on we will provide you some kind of basic syntax and all of the things about Pythons. And in the first session, myself, I am Suman Dhungel. I'm the managing director of Nepomics Biotech, and I will be providing you the basic information about Python and drug designing regarding different modules. And then later on, our research assistant, Mr. Abdul Majid, he will be providing you some basic learning things such as use of different syntax and a lot of other things. You can use data types or different other sub modules that can be used in Python. So he will be dealing with that session in the later half of this event. And talking about our company, Nepomics Biotech has been established in 2021, and we have continued to do different stops regarding natural product drug discovery and conducting different kind of webinars and workshop on drug designing. We have already conducted three different sessions regarding molecular docking, and we have also organized uh, 2 to 3 different webinars regarding polydactyly, as well as there was one presentation regarding cyanobacteria that can be used for biofuel production. And we are also providing some professional services on CAD related thing, molecular docking, homology modeling, in silico pharmacokinetics, a lot of other stuff, basic bioinformatics as well. And apart from that, we have been involved in natural product drug discovery, as well as natural product formulation things, such as we have 4 different products right now. These are all natural product derivatives, and some of the premium product includes mosquito repellent, natural that is a natural spray that has been formulated based on the chemical compounds that can be found on essential oils. We basically use essential oil for formulation of different kind of natural products. Apart from natural mosquito repellent, we do have some other products, for example, anti-hair loss oil and pain reliever oil and room freshener as well. And in the future, we are planning to explore all other things regarding formulation of natural products that has been available in local market, or you can see we can develop a lot of this kind of natural products in Nepal, original products, so we can do a lot of things in the future as well. So we are particularly focused on natural product drug discovery. So let's start this session. So let's introduce Python first of all. So Python is simply a programming language that can be used for different sort of uh, things, such as you can say data analysis or different other scientific computing as well. And further, we can use AI-based drug discovery, and in that context as well, Python is very important. So in case of drug designing, especially in silico drug designing, we use Python especially to create a different sort of file formats and visualize those data. Or you can simply say we can use Python for drug designing in case of molecular docking or molecular dynamic simulation, and it provides basic platform for other different kind of modules that can be inserted into Python, and we can visualize and we can compute those things. And in case of installing Python, you can just go to this provided link, and you can download Python program there. Currently it's running 3.12. You can download that current version, and you can install based on your operating system, for example Windows.
Excuse me, Suman. Your screen is stuck. I think so. Reshare it.
Okay, let me do that.
And also go with the full screen, please.
you getting this screen?
Yeah, it's fine. But
Are you
yeah,
getting the full screen now? Okay. Can I continue, Abdul?
yes, you can continue.
Okay, thank you. Thank you for reminding. So you can install Python on based on your operating system. And apart from Python, I've also provided a Jupyter notebook that can be used during data analysis, and you can use those notebooks as well. And in case of Python, we use different kind of libraries. For example, NumPy for different numerical operations, Pandas, ByPython, RDKit. I will be basically focused on Python and RDKit because Python and RDKit are very important in molecular docking, or you can simply say dock designing. So in case of Python, we use it for sequence analysis. I've given some example, that is one module sequence IQ, which is used for reading and writing the sequences. And in case of RDKit, we compile chemoinformatics and bioinformatics together there. For example, you can say you can use RDKit for file format conversion, for example, PDB to PDBQT, or else in using Open Babel in the RDK as well. So in this way, we can use different kind of libraries for the processing. And these are the basic syntax that we can use in Python. For example, variables and data sets. I've given the some of basic syntax there. In case of numbers, we use int, that is for that represents for integer. Whereas in case of float, represents for the numbers that has decimal points. Whereas some of the strings are given there. These strings are the sequence of characters, and it is abbreviated as str, and it is a sequence of characters represented in
Suman,
quotation, that is quotes.
again happened. It's stuck.
Maybe because of internet issue.
Yes, now it's fine.
Okay.
So control F5.
Okay. Then apart from that, we use dictionary as well, different sort of dictionaries that are used for, okay, let me talk with list first. So in case of list, it is abbreviated as list, and it is used for collecting the ordered collection of different items. For example, same sort of example for let me give you an example. For example, if you have different objects in the same category, for example, fruits, let's consider fruits. So banana, mangoes, or you can use this sort of data, and that is called as list. In case of dictionary, it is used for some unordered collection. For example, if you are taking statistical data, for example, in case of demography, we collect name, gender, or you can say profession, etc. So we can use this kind of data to create this dictionary. And in case of control structures, we use different conditional statement loops. I've given some example of conditional statement. In case of if, we use this block of code, if the condition is favorable, or you can say if the condition is true, then we use if as a control structure. Whereas elif, it represents for elif, else if, sorry. So it checks the previous, if the previous statement is false, then it checks the another condition, okay, that is represented by elif. And in case of else, it is a block of code where none of the previous conditions are true, then we use else. And in case of loops, there is for as well as while, designed for different sequences, and we use this kind of loops as well. So I've given one example of simple sequence, simple syntax over there. You can use drop design in double quoted. So in case of that is simply an example of string. So let's introduce bioinformatics. So I hope you all are familiar with basic bioinformatics. So we can use bioinformatics and for different sort of data analysis. So in case of bioinformatics is a subject. It is a computational tool, or you can say computational techniques that we use to interpret different biological data. It combine mathematics, basic science, and the information technology as well. So in case of drug design, bioinformatics is widely used in drug designing, basically for identifying the drug targets, and we also can analyze the genetic variation, mutation sort, and other things regarding genetic variation. So and later on, we can also analyze the molecular interaction using different other tools in bioinformatics. So this is a basic idea in bioinformatics, and um, we have also done one basic bioinformatics course a year before. You can go on our YouTube channel and check that. So in that case, we have clearly mentioned that while performing multiple sequence alignment, we can simply analyze the drug targets, or you can say active site residues present over there in the sequences there. So you can go through there and check those things as well. And let's talk about BioPython. So BioPython is one important module in Python programming language. So it is used for sequence analysis. Simply, we can read the sequence with that. We can write the sequence, or we can analyze the sequence. For example, multi-sequence alignment, or for constructing file engine tree. A lot of things involved in BioPython. And if you are using molecular docking tools, for example, MGL tool or Autodock tool, then if that just support the Python 2.7 version. Okay, so in that case, if you have Python 2.7 or the version before than that, then
Excuse me,
you will
Suman.
not get a PEEP. Okay, PEEP is a package management system which is used to install other software.
Hello.
Yes.
Excuse me, Suman.
Hello. Sorry,
Your screen is stuck again.
sorry to interrupt. Can you make it full screen like slideshow feature and continue again
Control.
because it is
Yeah.
taking time and
Con-
again?
I'm
Suman,
trying to
just
explain right now.
control. Just press Control F5. Control F5.
No, no, I've already done it. Okay. Is it now working?
No, it's not the full screen, right? Just press Control F5. Maybe it will be okay.
Let me.
And also you can share with me so that I can open from my side. Then you can go through it.
I think now it's okay. Is it?
Not.
I think it is stuck in one particular window. I think you are sharing window instead of whole screen. I think
Let me
that's the
share the
problem.
Maybe.
entire screen. Okay.
Maybe.
Maybe because of that thing.
Share with the entire screen. Maybe it will help.
Okay. Is it fine now? Is it fine?
It's fine, but just make it full screen.
Okay. Is it?
Yeah, it's fine.
Is it
Yeah,
visible?
Yeah,
it's
yeah.
fine.
Okay. Okay.
Thank you. Thank you.
Okay.
Thank
Let's
you.
continue from the start point. So okay, if you do have MGL tool or Autodoc tool, then you will get Python 2.7 over there. So in that case, you will not get PEEP package there. That is package management system to install various other software. For example, some other models. Later on, I will share you. For example, RDKit and other models. So we cannot do that thing. So in this case, you can just run the multiple program creating an artificial environment, but I don't prefer doing that. So you can just eliminate those things, and you can install the latest version of Python. In that latest version, you will get PEEP already installed over there, so you can easily optimize those things, and later on you can process accordingly. So here I'm talking about BioPython. So let's continue that. So in case of BioPython, we use this module for generating and reading sequences, sequence analysis, multiple sequence alignment, or simply we can say file genetic analysis as well. So it's a very important tool, um, a very important module in Python. I've given an example of sequence retrieval. So I've put one comments or quotes that you can see on green highlighted portion, and in the right hand portion you can see the results obtained for particular sequence. That is one sequence that has been the sequence ID has been given over there, and it is a nucleotide sequence. And if you want to run any kind of protein sequence, then you can just edit that nucleotide into protein, and in the upper hand portion of that part you can see interest email, so you can edit that email ID and you can put your own because it is used for storing information by interest. So I have used interest to derive the sequences there. You can simply do that thing. I will later on provide this codes, or you can see I can send you the codes. You can do it by yourself. I can also I will also visualize other tools as well. And in case of sequence analysis, or you can simply say for using for sequence alignment, we use cluster series, and we use cluster series along with Python, and we can use that, or we can also perform multi-sequence alignment over there. And for reading and writing FASTA in Zinbank file, for in this case we use sequence IQ. It is another model that comes up with Python. So we use sequence IQ. It is used for sequence IQ simply stand for
Sequence IQ simply stand for
I for input and
I for
O
input
for
and
output.
O for output.
There is someone who
There
is
is
audible, so
someone
can you
who
just
is
mute your
audible.
phone?
Yes.
Okay, let's continue. So that is one module in by Python, that is sequence IQ, which stands for sequence input and output. So input is used for reading the sequence and output is used for writing the sequence. You can use this model to write the sequence, or you can simply copy the sequences in FASTA format, and you can just create a pathway over there and you can upload that, and in that node you will get the sequence ID there. So the result has been given in the right hand side. In this way you can use by Python for sequence analysis, or you can simply say reading faster gene bank sequence using sequence IQ. So let's move on to ADMET now. So after doing that, ADMET is a very important process in drug designing. It is a it is used in silico pharmacokinetics, and ADMET it simply stands for A for absorption, D for distribution, M for metabolism, E for excretion, and T for toxicity of particular ligand molecule. So in case of drug designing, we go through different phases. So in that particular phases, we just create a library of some ligands. We do molecular docking, we do simulation, and various sort of wet lab things. So in that case we simply do the in silico pharmacokinetics, or you can also do in vivo pharmacokinetics as well. So in this case we analyze different property of drug, okay, or you can say a different property of ligand molecules. In the preliminary phase, we will analyze for the drug likeness of the ligand molecule. If it passes those different parameters of drug likeness, then we will later on move to different other phases. So in this case, pharmacokinetics is very important, and it can also screen the ligand molecules, or you can say drug-like molecules, and we can eliminate some of the unlike molecules, and we can take those drug-like molecules for further screening. So these are the things. In case of absorption, we use different parameters in distribution, metabolism, excretion, toxicity. There are different parameters. We use different online tools for analyzing those parameters. For example, we have already explained these all things in you can say external software thing. For example, PKCSM or Swiss ADME or ODC, or a lot of online tools are there, so they can examine the admit parameters over there. But in case of Python, we use command prompt, or we can use different codes, and we can generate the admit properties, or you can analyze the admit parameters of ligand molecules, or you can say drug-like molecules, or even drug molecules. So so admit is very important in drug designing. So in Python, we can create different tools, or we can install different tools and create some libraries and analyze the pharmacokinetics property, admit properties of ligand molecules. For example, RDKit is the basic tool used for you can say Lipinski rule of five, that there are different five parameters that needs to be passed for any kind of ligand molecules to consider as a drug-like molecule. So we can use RDKit. We can install RDKit in Python using that command. I have given that command on green highlighted portion. You can use that command on your command prompt, and then you can install the RDKit over there. And for installing RDKit, you need to have Conda. Okay, so it's a version of Anaconda, so you can get that. I will later on provide a link. You can download that Conda, and then you can install that Conda. And after installing the Conda, you can simply install the RDKit. So after installing RDKit, you can analyze drug-like nature, or you can say simply say ADMET parameters. In case of RDKit in the preliminary section, we will be analyzing the log PS, so that relates with the solubility of drug. So the solubility parameters, or you can say the range of solubility in the drug, can be analyzed, and later on topological surface area and any other drug like parameters can be analyzed through RDKit. And later on we can provide the codes for different parameters. For example, Lipinski rule of five, hydrogen bond donor, hydrogen bond acceptor, or you can say molar refractivity. So we can give different commands, and then we can analyze the results over there. And there is another module as well, deep game, which is another you can say module which is used for drug discovery. We can use deep game for analyzing the in silico pharmacokinetics as well. So this is the basic command I have given over there to use for log P and solubility analysis. So this is another command for Lipinski rule of five. There are just four, so you can insert one more there over there. You can just write the codes present over there. I will give this code in another file present over there. So let's go to molecular docking now. So after doing in silico pharmacokinetics, we go for molecular docking. Okay. So if there are some ligand molecules that has um, that is better, what you can see, Lipinski, they have passed the Lipinski rule of five, and they have shown great pharmacokinetic property. Then you can check that into different receptor, or you can dock that particular ligand into different receptors based on their uh, their preliminary examination. For example, you can use different online tools. In case of that, you can use PASS or any other tools to predict the, you can say, predict the biological activities of those kind of ligand molecules. And if once you have figured out the receptor, or you can once you have figured out the target protein, then you can come back to molecular docking, and then you can prepare those ligands and protein molecule and perform molecular docking. So it's a very important step in drug designing. So it's basic. The basic idea of molecular docking is to find the best conformation of ligand molecule that fits into the active site of receptor molecule. So in this case, we analyze the interaction pattern, we analyze the binding nature of ligand molecule, and we also analyze their binding energy. So all of these parameters are very valuable in drug designing process. So this is the major is application of drug designing, and we can optimize, we can increase the efficiency of particular ligands as well in this process. So we use different kind of tools and libraries in molecular docking. For example, Discovery Studio Visualizer. So Discovery Studio Visualizer is visualizer tool especially. So it is used for visualizing the interaction pattern of this complex molecules. Complex signifies the dog complex over here. So you can also use Pyrex. So Pyrex has already installed Autodoc Vina over there. So you can use Pyrex for screening the ligand molecules. You can use Autodoc Vina. Vina is widely used. It is academic software. It can be used for performing molecular docking. And later on, you can use RDKit and OpenBabel. So in case of OpenBabel, it is basic tools for converting file formats. So in case of molecular docking, you need different file formats. You need to convert the file formats. For example, you need to convert PDB file format into PDBQT, or sometimes you need to convert some kind of STF to mole file format, or so many other file formats. So in that case, you can use OpenBabel. And if you are working to the structure of compounds, then you can also use external softwares for creating structures. For example, you can use different organic chemistry softwares, ChemDraw, or you can say Chem Informatics. The Chem Informatics tools are present over there. You can use this kind of tools to create a structure and get a you can say smiley string or HTML file format, or you can create this kind of file formats, and you can come back to OpenBabel and convert those file formats, and then you can use that file formats into molecular docking. And for setting the environment for RD kit, in case of, or you can say OpenBabel in molecular docking, you can just use this code. And in case of Pyrex, you can go through that link provided there. You can install the Pyrex and you can do the molecular docking thing, or simply you can also do molecular docking using different commands. I will show that later on. And in case of molecular docking, firstly um, you need to prepare the ligands. Okay, you need to prepare the ligands as well as receptor. So in case of ligand, you need to obtain those smiley string or ST file format, and you need to minimize their energy, and you need to optimize it first, and then you need to convert it into PDBQT file format using OpenBabel. So in this case, in this process, we prepare the ligand for the analysis or for the molecular docking. So you can see one common present over there. You can edit that ligand thing, and then you can convert the STF. There has been given the STF file format of ligand. So you can convert that STF file format into PDBQT. And next, I provided you for the preparation of receptor. So in case of receptor, that means it's a protein or an enzyme or any DNA molecule. So you need to obtain that receptor from different databases. For example, protein data bank. If you are using protein or enzyme, then you can go through protein data bank, and you can just extract that protein first. That will be the PDB file format of that receptor. And in that receptor, you can get a lot of other different molecules which are not required into molecular docking. So it can create different unwanted binding over there. So you need to remove this kind of molecules. For example, water molecule or hydrogen or any other hetero molecules that are not important in the process. So make sure that you go through the literature review first, and then you need to remove those heteromers. For example, in some cases, there are some kind of molecules that can interact with the ligand molecule. Okay, so you need to know the values of those kind of heteromers, and if it is not important in molecular docking, then you can just remove it. But make sure you are confident enough to do that. So, and next you need to convert that PDB file format of that receptor into PDBQT, and you can use all. For example, I have written Autodoc tool, so it's a very older version. So you can use a newer software present over there. You can use online as well, online tools. So in this way, you can prepare the receptor. And I've forgot to inform that you need to minimize the structure, and you need to minimize the energy of this receptor as well, because we need to prepare some optimized receptor. So in that context, we can use force field to do that things. Different kind of force fields can be used over there, used for scoring function as well later on in molecular docking. So you can use this kind of things to prepare the receptor, and you can we can perform the molecular docking. So in case of running docking simulation, you can use Autodoc VNet. So in this case, first of all, you need to figure out the active site residues. You need to figure out the dimension of active sites present over there. You can, if you are using the standard protein, or if you are using a protein that have native ligand present over there, then you will get the basic information of active site residues present over there. So you just need to define the what you can say Okay, you need to define the dimension of that active site residues, and then after identifying that dimension, you need to put that values over there. For example, in the fourth, 1, 2, 3, 4, 5. Okay, in the fifth column, you can row. Sorry, in the fifth row, you can see there I've given the center and box size. So box size and center. Center means it's a dimension of active site residue. So it is a dimension of active site present in the receptor. So you need to figure that out first, and then you can just insert the values there, and then you can also okay, in if you are performing molecular docking in the autodock tools, so you can see the grid blocks present over there, or any other docking tools, you can see the grid blocks present over there. So this box size means it's a grid box that can be generated, or the basic information is that the size of that grid box. Okay, the dimension of that grid box. So whether you if you are performing external docking, then you can use discovery or pinehole, and you can get the dimension of this box, and then you can insert those values present over there. And then later on, exhaustiveness and different poses. So in case of exhaustiveness and poses, it is an output um, parameters that can be used in molecular docking. So poses means you generate different poses. You can generate 8, 20, 40 multiple poses. In case of Autodoc, Bina normally generates 9 different poses, and you can later on analyze those poses based on the RMST value and interaction pattern, or you can say interaction residues present over there. If the ligand is inserted into the active site with optimal binding energy, and the key residues are present over there, and they have the interaction present there, then you can select those pose, and then you can analyze the results, or you can simply take for further simulation. And later on, you can analyze those results. I've already mentioned it. So you can analyze those results using PyMol and different other visualization tools. Simply you can say Discovery Studio Visualizer or any other visualization tools, and you can identify the key interaction pattern, or simply key interaction residues present over there. And then if it is feasible along with the binding energy, then you can simply take that. So there is one comments given there. So it's a comment basically related for molecular docking result analysis using RDKit, and you can see chem over there. So chem is one model present in RDKit that analyze the chemoinformatics things in the molecular docking. So it's all about the basic thing on Python programming. And now I will present you one Word file. Maybe you are getting this Word file. So in this, you can simply follow those steps, and you can do the thing. For example, in case of downloading Python, I've given the link over there. So it's a basic, you can say it's a home page of Python. So you can go to this home page, and you can go to download section, and based on your operating system, you can download those things, download the Python programming. For example, it's showing 3.1 to 4. It's a recent version. You can download this, and uh, in the second line, you can see is a command pro. You can take the Python and pip install over there. So in case of recent version, you can get pip install over there. So using that command, you can simply identify which version you have installed in that particular moment. So you can analyze this version of Python as well as pip. So you can see this output that we can get from command prompt, and right now it's showing Python 3.12.4 and pip 24.0. So you can simply use those things. And after that, in case of installing by Python, you can use this command prompt pip install by Python, and you can get this result. And if you get any kind of problem in case of installing Python, then you just need to set the environment parameters. You can go to control panel, and you can edit the pathway present over there. You can just copy those pathway where you have installed the Python, and then you can run that, okay, easily. And I've given an example of these sequences that I've already presented over there. You can edit the email ID and nucleotide product sequence ID there, and then you can use, if you are using protein sequence, then you can edit that nucleotide to protein present in this code, and you can fetch it. So the result will, so in case of this, okay, in case of reading these sequences using Python, you can use two different options. So if you are using command prompt, so if you are using command prompt, you need to create a text file format. So in this case, in this demo class, I have prepared one text file format of one particular gene, that is SCN90. It is a gene related to insensitivity of pain. It is a genetic disorder. So you can create this kind of file format, text file format, in any of the directory, and then you need to go through command prompt, and then you just need to figure out, okay, you just need to figure out where your text file format is. If your text file format is present in desktop, then for example, in my case, I prepared one file format, text file format in my desktop. So I just copy this, okay, directory, and then I just run this code, okay, in the command prompt. After running this code, I will get this results. First of all, you need to change the directory where your text file format is, and then you need to run this code. After running this code, you will get the result. So you can read this sequence. Okay, you can get the excision number as well as FASTA sequence of this particular gene. And later on, if you want to do this thing in Python interface, so you can just open Python, and then you can just run those codes. Okay, you can just copy and paste that code. For example, this is the code, this is the code, and you can just paste that code into Python, and then you can get the result. Okay, and then okay, I've already told you that while reading FASTA and Jinping 5, we need to have one particular model, that is sequence IQ, that is output and input and output module. So in this particular model, you can just run those codes, and then you can get the result, or you can just get the sequence ID of that particular FASTA sequences. This is the one. And in this case as well, you can do in both ways, using command prompt, or you can also use Python interface directly to run this code and get the results. So is it, it has been given over there. So, and later on for ADMET analysis, so you need to first install Miniconda, or based upon your system you can also install Anaconda. So it's a premium version present over there, so you can also install Anaconda or Miniconda. So I have given the link of Miniconda over there. So Miniconda is particularly used for installing RDKit. So in this case, we need to have Miniconda installed. So you can see the home page of this Miniconda. You can see the latest Miniconda installer link by Python version. So you can go through that, and based on your system, you can just install this Miniconda first, and after installing the Miniconda, you can install the RDKit. Okay, and after installing Miniconda, you can get one command prompt like a structure, that is one command prompt of our system, and next is Anaconda prompt. So you need to open that Anaconda prompt, and then you need to create a Conda environment. Okay, without creating this particular environment, we cannot install RDKit, because we need to have this particular environment present over there. Okay, so that's the first case, and you need to create the environment, okay, for installing RDKit, and you can follow that code, and you need to activate that environment. There is the code present over there, and then after that you can install the RDKit, and you can verify the RDKit present over there, and this is the output you can get while installing RDKit. And then I've given one example aspirin for calculating log P, that is the basic parameters in drug designing in case of in silico pharmacokinetics. So I, I've given an example of aspirin. So I've created one file format, that is text file format of aspirin, that has been saved in desktop file format, desktop file. So I just need to run this codes. So here it has been given that the smile string of aspirin. So if you are running any other ligand, any other drug molecule, then you need to just edit that string, okay, smile string, and then you can write the name of that particular ligand or drug, and then here it is. Okay, you can run this, and you can generate two different parameters, two different things. One is log P and another is topological surface area, which are very important in silico pharmacokinetics. So you can do that thing, and then you can get the result. Okay, there it is. Log P and TPS, a topological surface area of aspirin molecule. And then these are the basic directory. First of all, you need to open the Conda prompt, you need to activate, and then you need to navigate those file formats present over there, and then you can run that and apply the codes. And then if you have used text file format, you should not forget to use the extension file txt. Okay, that's the thing, and you can get the result. It is the result of RDKit, using RDKit for calculating log P and topological surface area of aspirin molecule. Log P is basically used for solubility. TPSA is also basic parameter for solubility that can be used for drug availability and absorption. Different parameters can be analyzed in that particular model. And for Lipinski rule of five, you all know that there are five different parameters used for the Lipinski rule of five. The molecules need to pass this uh, parameters or pass these guideline values. So in this case, I have used aspirin as well. So you can edit that small string of aspirin and you can use your own drug of interest. You can analyze the drug likeness of Lipinski, drug likeness of that particular drug or ligand molecule. So in this case, molecular weight, adjacent bone donor, adjacent bone acceptor, it can analyze these things. And apart from this, log P and topological surface area, we have already analyzed that. So I haven't put that over there. If you haven't used the previous code, then you can just write the code. You can copy that code and then you can run this code. Okay, and then continuing from the above. Okay, if you are running Python script directly, then Anaconda, or you can simply say Anaconda prompt, then you need to copy above the steps and then you can run it and then you can get the result like this. For example, in case of aspirin, the log p value is 1.31, which does match with the previous one, and topological surface area as well. And apart from that, the molecular weight, log p, as a bone donor, as a bone acceptor, there are parameters. Okay, there are specific guideline values. You need to follow that guideline values. There is log p value, it should not cross 5. There should be certain parameters. Okay, so you need to analyze those parameters first, and if your drug molecule falls under that category, then you can get the result like this. For example, in case of Lipinski rule of five of aspirin, aspirin is already a drug, so it says that the aspirin passes the Lipinski rule of five and it has a drug-like nature. That is true. And after doing that, you just need to do molecular docking. If you are interested in molecular docking, then you need to install first you need to install OpenBabel, because OpenBabel is already I have mentioned you that OpenBabel is used for file format conversion. So you need to install that OpenBabel, and if it is not working, then you need to create a, again you need to go through a control panel. You need to go to control panel and you need to edit the system variable present over there. You need to identify the path where your mini conda is located, because if you have problem with conda installation, okay, or if you have problem with OpenBabel but it is not running, then you need to first define the pathway of mini conda. There is mini conda file, and in that mini conda file there are certain sub files, for example scripts or tag files or different other file formats are present over there. You need to find the conda exe. Okay, for once you find the conda exe, then you need to define that pathway. For example, in my case, I have figured out that my mini conda is installed over there in the program data, C drive of my program data, and then in the scripts I got conda exe. Okay, and then I just need to define this path, and then I need to edit the system variables. I need to define the pathway, and then I can easily run this OpenBabel. Okay, and after getting that, you need to check the OpenBabel version, and if it shows there, then you are good to go. And if it is efficient, then you need to again create the system variables, or you need to define the pathway for OpenBabel exe as well. Okay, and in the similar pattern, you need to figure out where your OpenBabel exe is present. In my case, I have found that in case of bin file of library of Miniconda 3, there is OpenBabel exe. So In the similar way, you can find the open babel exe, and then you just need to create a pathway, and then you can go through that. And it is a result of installation. Here you can see Open Babel 3.1.0 is present over there. So you can use this Open Babel for file format conversion. For example, in case of I have converted the smile string of aspirin into PDB file of aspirin. So once you convert this, you will get the PDB file of aspirin, and it will be saved in that particular file. Okay, where your command prompt is currently running. In my case, it's on administrator of user. Okay, you can get that, you can get the pdb file downloaded into that particular directory. And then later on, in case of molecular docking, you need to first figure out your receptor protein. For example, I have given an example of cox, or aspirin docked into cox receptor. Cox is a cyclooxygen receptor, and aspirin, we all know that it is a anti-inflammatory drug. So Cox is suitable for its binding. So first of all, you need to download the Cox receptor file format. You can get that by running this code, or you can go through that, and then you can generate the PDB file of the particular molecule. And this 6COX is a PDB ID of cyclooxygen. You can get that from Protein Data Bank or any other data bank as well. You need to extract the particular ID of that particular database of that particular receptor or protein or enzyme. You can say anything. Okay, you need to get that ID, and then you need to edit that box, or if you are using any other product, you need to edit that ID, and then you can run this command. After running this command, you'll get the result, and your cox file, pdb file of cox will be saved into that particular directory. And then after that, you need to prepare the protein as well as ligand for molecular docking. In case of preparing protein, you need to as I have already mentioned you, that there can be unwanted residues or unwanted molecules present over there, so we need to eliminate those kind of unwanted things. So in this case, you can eliminate water or any other heteromers, and then you need to add a polar hydrogen to the protein, so that it is easier for that protein to bind to the particular receptor. And you can use this command. For example, this command says that it's a conversion of pdb file of 6cox to the clean one. That clean one means it will remove, or it will eliminate the unwanted residues, for example water or any other heteromers. And after that, you can just convert that cleaned one into the pdbqt, because we need pdbqt file format for molecular docking. So you can do this by using this command. And after that, you also need to prepare the ligand molecules. So you can use this. For example, in my case, I have used aspirin. So the PopChem ID of aspirin is given over there. You can go to PopChem or any other ligand database, and you can extract the smile string, or you can also convert the STF file format into you can say you can use STF, or you can use any other file formats, but you need to use the right code. Okay, so in this case, it has been used, smile string has been used, so you need to create a pdb qt file format of aspirin for further processing. And later on, in the third step, you need to run the autodoc. So in this case, you need to first use one configuration file format. So in case of this configuration file format, I've used the receptor name 6cox clean. That is, I want to use this receptor for the molecular docking. The pdb file format should be there, and the ligand is aspirin, and its pdbqt file is there. And I have defined a random number. Okay, you need to identify based on your binding site. Okay, I have used this random number. So you need to first go to database, or you need to go to database or any other literature source, and you can find the dimension. Or you can also simply upload your protein structure into Discovery Studio Visualizer or PyMol, and then you can get the dimension of that binding site. Okay, and after getting that dimension, you need to copy and paste those values, and then later on, this is the box size, and then you can adjust all of the things based on using different external tools. And then later on, you need to run the autodoc. Okay, and in this case you need to first install Autodoc. You can go to Scripps Research Institute, you can get Autodoc Vina over there. You can simply, it's a very simple thing, so you can just download Autodoc Vina, and then you need to define the pathway of Autodoc Vina as well. For example, it is normally saved in program file of Scripps Research Institute, so you need to figure out the exe Vina exe file, okay, present over there, and then you can use this code and then you can run that. Okay, and after you perform molecular docking or after you run this command, you will get this result. Okay, that means it gives the result of your molecular docking. In this case, in there are they have generated 9 different poses, and you need to analyze based on their uh, energy as well as binding nature. So in case of number first, you can see minus 6.2, which is good, and we can just go through and then we can see the interaction pattern. Okay, and then you can use RD-Kit for analyzing the docking results, or simply you can use external visualizers or Discovery Studio Visualizer or Pymol for generating the interaction pattern. I will given that thing, and then you can visualize those things into the Pymol as well. So in this way, you can perform molecular docking using Python programming language. You can use this kind of codes for further processing, and then after that you can go through different other process, for example simulation or any other drug designing things. So this is all about the first basic introduction to Python for drug designing. If you have any kind of queries, then you can ask me, or else we will follow our next presenter, Mr. Abdul Majid. He will be introducing you for some basic syntax and how to use Python, basic Python for computing things, scientific computation. So, if you have any question, you can arise.